Naming ionic compounds with polyatomic ions follows the same rules that we used before. You're going to name the cation, you're going to leave a space, and then you're going to name the anion. So we're going to go through a few examples here. So I'm just pulling these from the worksheet that you just did. So if you have magnesium hydroxide, okay, and again I already gave you the name here, we're going to name Mg as magnesium. We are going to name OH. And in order to do this, we're going to look at the back side of our pink sheet. You're just going to need to look up the name of the anion. So you just are going to scan it and find it in this group. So you'll see you have OH minus there, so this gives us the magnesium hydroxide. Now you'll notice this one has the IDE ending. We didn't have to do anything to get that, so you're going to be copying exactly what's on your pink sheet, and you'll see that in the next couple of examples. For our next example, Al2SO4 taken 3 times, we are going to again name the cation. So our cation is aluminum, so we're going to write aluminum. And then we're going to look at our anion, which is SO4, so it's just a matter of coming over and scanning your list of anions until you find SO4, and you should find that fairly easily. Now I'm writing these on here underneath each other. They would be written in one long line. I'm just trying to keep the chart visible to you. So aluminum sulfate is your name. For this compound, Fe3PO4 taken twice, you're going to need to be a little bit more careful because iron is one of those groups that is not in, or one of those elements that's not in the A group. So we're going to be looking at our 2 irons, and we need to figure out which iron this one is. Is it iron 2 or iron 3? In this case, you always look at what the anion is, or the second polyatomic ion. So PO4 is a -3 element, or excuse me, -3 ion. So if you remember, we crisscross to get it. We basically undo our crisscross. And this one you had on your worksheet. So you might also be able to just reference this, that this is iron 2. So in this case, we need to specify which iron it is. So we're going to have iron 2 as our formula, or a name for our cation, and then phosphate, just here, phosphate as our name for our anion. Copper is also in your B group of the periodic table, so this is one you should be looking to see what you have available to you on the back of your pink sheet. And you'll see also there are 2 different charges available for copper. So copper and iron are going to be the 2 that you need to be most concerned with this. Now, if you do what we did with the last one and just try to undo the crisscross, you'll see that that would be a +3. But there is no +3 over here, so that cannot be correct. So you have to be careful and kind of isolate the entire group. So SO3 is a group, and then find that down here on your anions. SO3 is a -2 charge. Since there are no parentheses around SO3, that tells you that there's only one of that group. So the total charge on the SO3 is -2. In order for our compound to be neutral, our total negative has to be, or total positive has to be +2. So this tells you that this is indeed copper 2 sulfite. I'm going to overlap the table a little bit, but that is the proper name, way to name just one single line. They don't need to be stacked. I was just doing that for spacing purposes. I have another example of iron for you, so again we need to look at what's possible for iron, iron plus 2 and iron plus 3. Again, you'll notice there's a 3 here, so if you see that, you can kind of undo the crisscross, but remember there are some limitations with that. So if I show you the long method with this one, if you look, carbonate is a minus 2, 3 times minus 2 is going to give me minus 6. My compound has to be neutral because it's gaining 6 electrons, so something has to be losing 6 electrons. And then I'm going to do 6 divided by 2 this time to give me my charge of plus 3 on the iron. And again, you can see that that works to undo your crisscross, but if there's no parentheses, you need to be really careful with using that undo method. It doesn't work if there's no parentheses. Okay, doing this least common multiple idea, or number of electrons lost equal numbers of electrons gained, will always work for you. So then your name is just going to be iron 3 carbonate. So again, iron and copper are going to be the two that are going to be most difficult for you, so just be really careful with those. Okay, with this one, again, you want to visually break this into two parts, the cation and the anion, and again, it's usually the first element alone is your cation. So this one's easy because there's only one option for chromium, so this is going to be chromium. But do note that you do have a Roman numeral that has to be part of your name. If you just have chromium, you'll get it wrong, so you must include that Roman numeral 3 with it. And then it's just a matter of finding the C6H5O7 on your chart. Again, if you realize that chromium's a 3 and there's no parentheses with this, you'll be able to tell that this is, and then minus 3, and you won't have to look as much. So this is chromium 3 citrate. And again, that could be in one long line. We're just running out of room. NH4 is the only polyatomic ion that you have that's a cation. So you'll find that here, and its name is ammonium, so don't have to do anything else other than copy that. And I wanted to remind you, we have a sulfur here. You're not going to find sulfur as you scan down any of these lists because it's not polyatomic, so this goes back to the rules that we had done earlier. So you're going to go to the periodic table, and again, hopefully you know sulfur, but if not, you would look at sulfur, and then take off the ending of the UR and add the IDE. So this would be ammonium sulfide. And just one final example for you here. Hg is mercury. Again, that's a B group element on the periodic table, so you're going to need to find that one up here, and you'll see that there is a Roman numeral required for this one. So mercury 2, and then the NO2. Okay. You're going to come over here till you find that, and that one is right here. Notice spelling is going to matter because there's a nitrate and a nitrite, so it must be correct in terms of that I or A. And again, you're copying from a table, so I think you should be able to do that accurately. Okay, at this time you should be completing the back side of your worksheet that has polyatomic ions with that big grid on it, and see your instructor for the answer key when you're finished.